And this is Dr. V.S. Nishok from EC Department, SNS College of Technology. Here we are going to see the topic Application Specific IC Design Flow. Here is the outline. First we will be starting with the introduction to Application Specific IC, and then ASIC Design Flow overview, and then general specifications and design flow, and then tools used, and then summarizing. First, what is IC? It is full form, it is abbreviated as Application Specific IC. So here we are in this today's world, we are having different types of IC starting from analog IC, digital IC and mixed ICs, and we are having several configurations in it. So how we are designing the IC that starts from the HDL program, which is converted into a chip with the help of the electronic design automation tool that is named as a EDA tool. So that is the main tool used to convert the design representation in the form of HDL into a chip. And then ASIC is an non-reprogrammable IC which is designed in such a way that it needs the exact requirements for a specific application. If you are going for a mass market like mobile phones or any infotainment systems, digital TV, etc., so then ASIC is the best choice for it, because if you are going for a mass market with mass audience, very low production cost if you are choosing ASIC ICs, and low power consumption and very less size are main advantages of the ASIC ICs. And then coming to the design flow, here we are having starting with algorithm and implementation in HDL, logic synthesis, gate level netlist, logic verification, mapping, placing and routing, and then physical layout. So we are going to see this one by one. So initially algorithm that we are having whatever specification needed, so that is with that help we will be creating an algorithm. So based on that algorithm we will be going for the HDL program with the help of VHDL code or Verilog code or any schematic entry. So once that is done, so then it will be simulated, functionally whether the outputs are there or not. So that is functional simulation. And then coming to the logic synthesis. So using the synthesizing tool, the program that is Verilog or HDL program is converted into the gate level netlist as shown in the diagram. So that netlist will be in the form of a code that represents the local connectivity of all cells and wires between the cells. And then after converting into the netlist, post level synthesis will be taken place whether the netlist is working properly or not. So that is done there. And then coming to the logic verification. So after logic synthesis we are going for logic verification. So this logic verification step checks whether the obtained output is from the netlist is similar to the given algorithm. So that is checked through the logic verification step. And then coming to the mapping, placing and routing. So here if you see mapping, so mapping represents the technology that we are using, we are choosing from the library. So for example, in today's world 3 nanometer technology, 4 nanometer technology is possible while designing a chip. So like that, based on the EDA tool that we are using, so in which what is the technology we are having, that is chosen. So that directly represents the thickness and width of the components that we are using to design the circuit. So that is chosen with the help of the mapping. And then placement represents the placing the components how efficiently to reduce the area, to reduce the power. So that parameters are kept into consideration with the help of the EDA tool, and the placement represents the placing of the components that is needed for our design. And then finally routing represents the wire connectivity between the each and every components. And then so once it is done, then placement, that mapping, placement and routing is done, then final verification is taken place. So that is timing simulation, so that represents how speedily the circuit is working, the circuit that we are designing is working, so how efficient, that is checked with the help of the timing simulation. And then once everything is done, then finally the design is given to the manufacturing industry, and finally the ASIC IC will be manufactured through that industry. So these are the different steps that we need to follow, starting from algorithm up to the physical layout. So here there are different manufacturing companies like Cadence, Synopsys, Siemens, and then Intel, Magma Design Automation, providing different tools in order to design our circuit, our interested circuit for the IC design. So here are the tools listed and its functionalities. And then coming to the real-time application of ICs, where we are using the IC. So mobile SoCs, mobile system on chip, Qualcomm Snapdragon is the best example. Automotive ICs, so in the automotive industries, so nowadays we are using ICs, so there we can utilize this ASICs. This is a autonomous driving advanced system, and then infotainment, so navigation, tire pressure, so like such things are possible with the help of this ASIC ICs. And AI accelerators for complex circuits, this Google is using AI accelerators to design the circuits. Then finally here is the short comparison between the ASIC and FPGA. So if you are here seeing the features like customization, cost, speed, etc. So here this ASIC is slightly higher when compared with the FPGA, but for going for the mass production, while comparing with the FPGA, ASIC provides the better advantage when seeing all those above parameters and features. So here whether FPGA is reprogrammable, yes, but ASIC is non-reprogrammable, what we have discussed in the first slide itself. Once it is programmed, so that completely will be utilized for a particular application. So that is why it is named as a application specific IC. So at last we have seen about starting with introduction to the ASIC, and then we have seen about the ASIC design flow, and then step by step we have seen what are the things happened in the design flow in the front end and back end, and then we have seen the real-time applications where and all we are using this ASIC ICs, and then we are going to see the assessment part. So what does ASIC stands for? So application specific integrated circuit, that is the right answer. The two major parts of the ASIC design flow are front end and back end. So which HDL language is commonly used in RTL language? So here in the given option, Verilog or else VHDL is the right answer. So which of the following is a type of ASIC? So ASIC is the full custom, programmable, semi-custom, all the above, that is the right answer. Synthesis convert RTL into gate level netlist. So the logic synthesis converts our coding into the gate level netlist. So that is the right answer. So these are some assessment based on our today's topic, ASIC design flow. And then here are some reference books and websites, so where we can gain in-depth knowledge about the ASIC ICs. Okay, thank you all for joining this video. We can join in the next video.